Good evening, dear participants. Today we have a speaker as Dipu Kumari ma'am. She is lecturer in Government Polytechnic Buxar, and she has done her BTech from Nalanda College of Engineering, Chandi, in 2012, and then after that she has done her MTech from NIT Patna in Structural Engineering. She has got 5 years of industrial experience from 2014 to 2018 in rural water supply department in Telangana government as assistant engineer. And she was the part of esteemed mission Bharat program and was awarded as best engineer in 2016. Then after that, she switched her career to teaching profession, and she has 6 years of teaching experience from 2019 to present in in the Department of Civil Engineering in Government Polytechnic Buxar. She has also served as HOD in the Department of Civil Engineering, and she has also served as exam controller in the Government Polytechnic Buxar. As we all know that the Polytechnic institution provides us the junior engineers and various those engineers which will be serving as the building blocks, the basic foundation of all the engineering works. So she is providing her service to build for the nation building. So we can kindly introduce and we can welcome Dipu Kumari ma'am to present on the topic modern building materials. So ma'am, can you join and can you start presenting your slide?
Sure, sir. Thank you. Good evening, everyone. As sir has already told about me, I am Dipu Kumari, lecturer as well as HOD of Civil Engineering Department in Government Polytechnic Buxar. First of all, I would like to thanks the program coordinator, Dr. Anjani Kumar Tiwari, and the co-coordinator, Dr. Jitendra Pratap Singh, and the whole GEC Buxar team who are involved in this program for inviting me for this session. So without further delay, let's start the topic. I'm going to present, just one second. I'm sharing my screen. Sir, is it visible?
Yeah, ma'am, it's visible and you're audible.
Okay, sir. Thank you.
Continue कर सकते हैं मैडम.
Sure, sir. Sure. Thank you. So let's start. Today I'm going to present on the topic modern building materials. If I ask a question from the audience, how many of you think that bricks, cement, and aggregate, the so-called the traditional building materials, are the only building materials we rely on today? I presume the 100% answer will be in negative tone only. Because as we are approaching the modernization, the globalization, we are more prone to the culprit of the climate change. We are more prone to the culprit of the pollution and deadly disasters which are happening nowadays. Hence, to solve these problems, the world is focusing more on the sustainable materials, which are more efficient than traditional materials, and which is the need of the hour. As we all know about the Government of India program, India is focusing over the smart city construction, the green construction, where modern and smart materials are playing a very crucial role. So by the end of the session, we will understand what is the modern building materials, what is the need of it, what all materials constitutes the smart materials or modern building materials, and what all materials are used globally as well as in India. Apart from this, we will learn about what is its benefits, what is its limitation, and how we are using this material present in the present time. So if I talk about the modern building materials are nothing, it's so advanced, innovative, engineered, or so-called sustainable materials which are used in construction that provides better strength, that provides durability, energy efficiency, and eco-friendliness compared to traditional materials. Like compared to traditional materials like clay, bricks, and cement and all. If I group these materials to in a different categories, these modern materials group in certain group like smart materials. Smart materials are the thing which respond to environment stimuli, like when environment like self-healing concrete. We will see what it is in further slide. Other is eco-friendly or recycled material. Many of us are aware about the plastic road construction. Like that, plastic bricks are also being constructed and being used in the building construction field. Other group is bio-based construction material, such as agro bricks, which are made from the composites from the agriculture field, like wheat dust, rice husk, and all. Other is hemp bricks, which is also made from hemp tree. Okay, and the next group is high performance composite. It is like when concrete is mixed with certain polymers or certain bio-based composite, it behaves in a certain different way. Their performance is enhanced. That composite is called high performance concrete composite. Example is fiber reinforced polymers. Other group is digitally fabricated. The world is known about the 3D printed buildings. Even India have constructed many buildings related to 3D printed. This smart innovated technology. If I talk about the other examples, nanomaterials are also playing a great role as a modern construction material, as a smart materials. The other one is phase change material for thermal regulation. It's like an ice. When heat is increased, it melts. And when heat is cooled down, when the temperature of the building is reduced, it solidifies. By these properties, this material playing a role in the thermal regulation. We are going to see this all materials in a detailed way in further slide. This is next is photovoltaic glass. Can you imagine a glass can make the energy, the solar energy? That is photovoltaic glass. In a way, I can say these all materials, the modern materials, are the materials which are energy efficient, which provides durability, which provides high strength to the building. Already I have discussed the important part. Let's discuss once again. The modern building materials, what is the benefit of it? It increases the durability and strength of the structure. As the strength and durability is increasing, it means the life, the life span of the building, the life span of the infrastructure will increase. As we are focusing over the sustainability part, we are aspiring for sustainable infrastructure. This is the materials which are forcing us, which are moving to us, to us the sustainability aspect. It also helps in low maintenance. As example, self-cleaning glass. If we provide some nanomaterials in the glass manufacturing, that produces a self-cleaning glass. As I discussed, it also enhances the energy efficiency. It also, the functionality of the building is enhanced. 3D printing, this is the innovation in infrastructure. Apart from this, the disaster like earthquake, fire resistant, cloud burst, any other disasters, we can check by this material. In a nutshell, I can say modern building materials are essential for constructing sustainable, safe, smart, and cost-effective infrastructure for meeting the demands of today, that is 21st century and the beyond. Let's discuss each material one by one. First is the high performance concrete. It is also called the high strength concrete. It is just like a concrete only. So I can say it is a type of concrete which possesses the high workability, high dimensional stability, high strength. Because of this, we are using this material in high-rise building, long span bridges, heavy industrial infrastructure. It also gives low permeability that enhances the durability of the building. The high performance concrete possesses high modulus of elasticity. As an engineer, we all know about the role of the modulus of elasticity in building. Because of this high modulus of elasticity, it provides less deformation under the heavy load. Other advantages, if I would talk, it provides resistance to chemical attack. If I talk about how it would made, made by the way conventional cement concrete is made only, but along with conventional cement concrete like binder, fine aggregate, coarse aggregate, we add certain admixture to enhance the properties of the concrete, conventional concrete. That admixture like plasticizer, super plasticizer, that may be retarders, that may be air entertaining agents, water repellent, etc. In this, not just only materials will play a role, the proportion and the design we are using is also playing a role. The manufacture of the concrete are done in a such a way that resulting concrete will provide will give an excellent performance for the desired purpose. If I talk about the application part, it is used for constructing a structure which requires longer service life, which requires which require longer service life. Okay, such as oil drilling platform, such as nuclear power plants, offshore construction, long span bridges, parking structures, etc. Recently, when in news we have heard about our honorable Prime Minister inaugurated the world's highest railway arch bridge on Chenab River in Jammu and Kashmir, Riyasi district, which is 35 meter taller than the Eiffel Tower. In this also, high performance concrete is used that for enhancing the strength and durability in the extreme climates like the Himalayas extreme climates. If we talk about the difference between the conventional cement concrete and the high strength concrete, the conventional cement concrete that we use in building construction, its strength, compressive strength typically lies between 15 to 40 megapascal, while high strength concrete is generally having above 60 megapascal or 50 megapascal, that can reach up to 100 megapascal of the compressive strength or even more. It's all depends the proportion we are using in mixing in forming that concrete. Since conventional cement concrete, as it have good workability without special admixture, but high strength concrete, as I discussed, it needs super plasticizer to overcome the workability issue. Because of here in high strength concrete, we keep water cement ratio is very low. If I talk about the durability part, the conventional cement concrete provides moderate durability for the aggressive environment, while high strength concrete provides high durability as well as low permeability and resistance to chemicals. It convinces for the same load construction, the conventional cement concrete requires the thicker member. But if we are using the high strength concrete, it requires the slimmer section because it provides high strength. Hence, the space utilization is more space saving, as well as the dead load of the building is reduced in high strength concrete. Conventional cement concrete, economical and widely available, right? But high strength concrete, here economical part is downsided, and here strength matters a lot. So high strength concrete is of higher cost nature because of the addition of the special materials like admixtures. It provides, so conventional cement concrete, we have low modulus of elasticity that provides more deformation to the building structures. However, high strength concrete having high modulus of elasticity provides less deformation to the building structure. We have covered the benefits parts in earlier slide, like high load carrying capacity, reduced member size, high durability, longer service life because of reduced maintenance cost, and less deformation, suitable for pre-stressed concrete and long span bridges. As I have already discussed, I have already mentioned, high-rise build. It is used in high-rise building and marine structures. Let's look about the challenges part. The high concrete structure, the high strength concrete is of brittle nature because of the high strength the material provides. Because of this, we see sudden cracks and sudden fracture in the building. That is a main demerit of it. Here, workability is issue. So we utilize more superplasticizer. Because of that, there is a shrinkage and cracking risk. To overcome this, we need here more curing while forming this structure. It requires a special material. Okay. We need a strict quality control. Then only we optimize the strength. We optimize the high strength concrete performance. It is of higher cost, and the heat of dehydration problem is one of the main problem of the high strength concrete. This is the first figure. This is the Bandra Worli ceiling, Mumbai, which is constructed over the sea. Here, high performance concrete of M60 grades and above are used. It is designed in such a way that it resists marine environment, to resist chloride attacks and high wind speed. This one is Sardar Sarovar Dam, which is in Gujarat. Here also in the dam body part, large volume of high performance concrete is used in the dam body. So that to provide higher strength, impermeability and resistance to alkali aggregate reactions. This I have already talked about the Chenab bridge. Here, in anchoring this bridge, although it is a steel bridge, but for anchoring, we have used the high performance concrete. This is Eiffel Tower, the world's tallest building. Sorry, Burj Khalifa. Okay, sorry. This is Burj Khalifa, the world's tallest building. In other places, if I talk, in Delhi Metro, Mumbai Metro, Bangalore Metro, there is also use of the high performance concrete to overcome the extreme environment of the ground condition and all. Let's come to self-filling concrete. Before discussing, if I say, have you ever seen or heard that even concrete repair itself? I think, is it possible? Yes, it is possible and it is there. That is self-filling concrete. This is the concrete which heals itself like a living tissue. See, the figure first says when a structure develops or cracks by any chance, in a first, if this structure is made with self-healing concrete, in a first wing, its gap is like this. In a second wing, like this, and in third wing, like this. It means in just 3 weeks, we can overcome the problem of the cracks. But there is some limitation. At present, we have limited capacity, just 0.5 to 1 mm we can heal up to. It is of two types. Self-healing concrete, we use some bacteria in the concrete and some capsule-based elements in the concrete. While forming concrete, we use bacteria like Bacillus subtilis, Bacillus pasteurii, which activated when a crack is developed and when anything enters this crack, like the environment smell like water. After activation, that bacteria releases calcium carbonate, which fills the gap over the time. Like that, capsule based also works. It releases some adhesive material which heals the cracks. It's a very I can say it is in a study phase, like in the IIT Kharagpur. IIT Kharagpur constructed a water tank on a pilot base in Gujarat and demonstrated that we can improve the service life of the structure by 20 to 30%. One road by self-healing concrete is constructed in Karnataka by the help of the University of the British Columbia. If I talk about the advantages, it increases the lifespan of the structure because of the cracks which we are immediately resolving by the concrete itself. It reduces the maintenance and repair cost. Say, suppose if a crack happens in a concrete or a column, what will happen? The water is ingressed in that crack. As we know, the concrete is capable in just compressive strength bearing, while the building tensile strength is beared by the reinforcement. Suppose if water enters that crack, what will happen? That reinforcement will rusted over the time if we are not repairing that cracks immediately, and ultimately the structure will collapse. To reduce that, we use self-healing concrete that increases the lifespan of the structure, and as well it reduces the maintenance and repair cost. It also improves the durability against the water and chemicals. It is of eco-friendly and sustainable nature. But the main challenge is it is of higher initial cost. There is some limitation. We can just we can just heal up to 0.8 mm width. It is still under the research stage, and it is still so the implementation for large projects is a challenge. Next is phase change materials. It is just like an ice cube, keeping a drink cool. Phase change materials stabilizes the building temperature. It is a substance that absorbs and releases heat during the process of phase transition from solid to liquid. And during this process, it maintains the indoor temperature of the building. How it works? What if the wall is made of some phase change materials? If phase change materials is added in concrete, what it happens when the temperature of the building is increased, that phase change materials absorb the extra heat and melted. During that, it cools the indoor environment. When in night when the room temperature is reduced, it releases heat to solidify and solidified. It's just like acts like a thermal battery. It is of many types. It may be of organic type, inorganic type. Like organic, we can in organic we use paraffin, waxes, fatty acids. In inorganic, we use salt hydrates, metallics like metallics, etc. If I talk about the application, we use in buildings, roofs, floors for insulation purpose. When solar energy storage, for solar energy storage, cold storage, and textile. By this application, we can derive it save energy, as for regulating the room temperature, we consume more energy. So by naturally through the help of the concrete only, we can save energy, and that too eco-friendly and comfort. But the same problem is of high cost, and its leakages. So next is composite materials. Composite materials are like the materials which are mixed with the concrete, or made by combining the fibers with resin matrix to achieve the higher strength and low weight, as well as enhances the durability. We can use like seeds if we are combining this fibers in concrete, we can enhances the strength of the concrete as well. This fiber may be concrete may be fiber reinforced concrete. If we are using glass fiber or carbon fiber, we can named as a glass fiber concrete, carbon fiber concrete, right? If I talk about the benefit of it, it enhances the strength of the building, strength of the concrete. Means the high strength to width ratio. It provides excellent stiffness and the durability, as well as it is resistance to corrosion and fatigue resistance. It provides fatigue resistance. Even it helps in overcoming the challenges of extreme environments like the earthquake. Examples I can say, this is glass fiber reinforced gypsum. we commonly call it is a rapid wall. This is used in uh, constructing the what we call okay uh, okay, this is yeah, this is mainly used in constructing the wall or the false ceiling we generally we see. Because of this, because of it named as a rapid wall, because of fast construction, it is even resistance to seismic resistance. It is of cost effective nature for housing or infrastructure if we are using glass fiber reinforced gypsum panel. Next, looking at now, I'm moving towards the masonry part, masonry block. We are seen previously the concrete blocks and all concrete part. Now moving for the masonry unit. Traditionally, what we have seen the clay bricks, red bricks. But in modern materials, there are there are many blocks, many bricks like the autoclaved aerated concrete blocks, fly ash bricks, even bricks are plastic bricks are also prevailing the environment. Okay, so then let's discuss about the autoclave aerated concrete blocks. It is of lightweight nature, which is formed by autoclaving a mixture of fly ash, quartz, cement, lime, gypsum, water, other like other materials like the lime and all. Because of this composition, its weight is reduced. Its weight is 3 to 4 times lower than the clay bricks that we call red bricks. Okay, because of this composition, it provide resistance for thermal and sound insulation. Even it is resistance for fire and pest resistant. Since its weight is very much low than the clay bricks, its advantages is like it reduces the overall building of the weight of the overall building, that is dead load of the structure is reduced. Even this block is very much big than the clay bricks, which increases the construction pace. Even as it is made from the fly ash, one of the composition is fly ash, it is eco-friendly nature. Even it is of energy efficient because of thermal and sound insulation. But limitation is higher in initial cost than the clay bricks. It requires skilled handling because of brittle nature. It is of brittle nature, which are prone to blockage. Even the availability is a concern. Next, if I talk about the fly ash bricks, next is the fly ash bricks. Again, this brick is of eco-friendly nature, which are cost-effective, stronger alternative to clay bricks. And as it is of lightweight, it provides high strength and made from a fly ash. we all know fly ash is a byproduct of the coal power plant. It is made by the mixing the fly ash, cement, lime, gypsum, sand, and molded and cured under the steam pressure. If I talk about the advantages, it provides higher compressive strength. It just like the first class brick. It is of lightweight nature, hence reduces the dead load of the building. It is of uniform shape and size. As a resultant, we require less mortar for plastering. It provides like autoclave building blocks. It also provides thermal and sound resistance, thermal and sound insulation. It also absorbs less water, hence the problem of the efflorescence, which we generally see in clay bricks, is avoided. So next, if I try to compare these three bricks, first one is clay bricks, second autoclaved aerated concrete blocks, and third one is fly ash brick. Raw material is clay, clay, cell, and water. Okay. Here, cement, lime, sand, even fly ash, gypsum, aluminum powder. Here, fly ash is the main component. In fly ash is the main component. Sand, cement, and water. Strength-wise, its a strength varies between 3.5 to 10-11 megapascal. While autoclaved aerated concrete, if I talk about, the minimum strength, it provides 3 to 5 megapascal. We can increase the strength of it, definitely. In fly ash bricks, the strength we achieve 7.5 to 10 megapascal. If I overall rated the strength wise, the fly ash brick is more suitable for our building construction. Density wise, again, this clay bricks and is more denser. So the weight of the building is weight of the structure is enhanced, increases. Thermal insulation, as I already talked here, very low thermal insulation. In a autoclaved aerated, we receive high thermal. In fly ash, moderate level. Third, sound, again, moderate, here, good and good. Eco-friendly, not at all. It consumes topsoil. Yes, it is eco-friendly because it uses less natural resources. Okay, here again it's a eco-friendly because of fly ash consumption. Cost-wise, though it is of low, and here it is high, and fly ash is approximately about the clay bricks. Durability wise, high, while autoclaved concrete blocks, though strength wise high, but it is of brittle nature. So we generally avoided autoclaved aerated concrete blocks. And fly ash brick, again, the strength wise is high. So overall, if I can say, the fly ash brick is of high strength, which provides thermal and sound insulation, eco-friendly. It is of eco-friendly nature, as well as the cost is also of about the red bricks only. Let's move for interlocking bricks. Interlocking bricks can be made from any material like the clay or the autoclaved or by the fly ash or autoclaved materials. It is designed in such a fashion that there is a groove, there is certain there is a groove or certain what do you call interlocking pattern are there, or projections are there, which helps in stacking or keeping these materials without help of the mortar. We do not need any mortar in this for constructing wall or the pavement or the boundary wall. It is, but its advantages is like, since we do not need mortar for binding of the bricks, it is of cost effective nature where we do not require plastering. It is of strong and durable nature, and it reduces the cement use. The construction by this is of faster pace. It is of eco-friendly nature because of less use of the cement and the mortar. Even it is resistance to earthquake because of the interlocking which are flexible. It provides the interlocking way of flexible nature. But once again, the limitation lies. It is not suitable for load-bearing structure or high-rise building. It requires the precision manufacturing that if we made this brick, or these projections are somewhat in a dicey manner, then we cannot group this. We cannot set these two bricks cannot set in a proper fashion. As well as the awareness in the about this material is very low in public, along with the availability is also a concern. So we can use this material in construction of the boundary wall or a small commercial building. Let's move for plastic brick. This is made from the waste. This is based on the concept of the waste to wealth. It is of eco-friendly nature because it is made from the waste generated in the industry or homemade. It is made of recycled plastic waste that sometimes mixed with the sand, concrete, and other binders. Okay. It provides durable, lightweight, and eco-friendly building materials that are cheaper than the conventional red bricks. It is resistant to water absorption and erosion. If I talk about the limitation part, it requires proper technology. It requires proper technology for large scale use, as well as the standardization and acceptance in the industry is a major concern. We can use this brick in pavements, in a boundary wall construction, partition wall, or disaster relief shelters. In short, I can say the plastic bricks turns waste to wealth by recycling plastic into durable, lightweight, and eco-friendly building materials. The other is plastic road. We all have heard, might be all have heard about the Ministry of Road Transport and Highway also encouraging for this road. This road is constructed by the use of the plastic along with the bitumen. If and that too plastic is of waste plastic, where India is, as we know, the India is, I think, third most polluted country. We are generating 3.3 million metric tons of waste plastic every year. But how we are using this material in construction of the plastic road? What we do, we first we clean the plastic waste, and then we shredded the plastic into smaller pieces. Then mix with it hot aggregate at 165 to 170 degrees Celsius temperature. Then bitumen is added, which creates a stronger plastic bitumen mix compared to the traditional bitumen road. If I talk about the advantages of it, what is the advantages of using plastic road? It utilizes the waste plastic, hence environment friendly. It even the reduces the project cost, the construction of road cost compared. Okay, it is more durable and resistance to water and wear and tear. If I talk about where in India it is built, in Chennai in 2002 itself, it was built, but just on pilot basis. In 2021, in Jammu and Kashmir, a national highway is constructed with the plastic material. Even in Tamil Nadu, if we search, about 1,000 kilometers of road is already built with plastic waste material. And there are several examples of the plastic roads in Guwahati, Indore, Pune, everywhere plastic roads um, is trending now. But the problem is we are unaware of the long-term impact of the plastic. We are long-term impact, how it is going to impact the soil, water, and human health. Even there is a concern over the microplastic pollution. Over the time, wear and tear will definitely happen in the road. This microplastic may cause the health issue in long term. That is the main issue of the plastic roads. Still, and this is here there is no proof, and still research is going on the plastic road. Next is bio-based material. Bio-based construction material like the hemp brick, which is made of the hemp plant. It is, but the limitation is it is used for non-load bearing wall. It provides insulation and sustainable. It provides insulation and sustainable construction building. Next, if I talk about the agro bio bricks, it is made of the humpers, husk rice, straw of the wheat and the rice, which we waste generally, which we burn, or the sugarcane bagasse, which are mixed with certain binders like the lime, clay, cement, bioresins. And it is of sustainable and eco-friendly nature. It requires low energy for preparation, but the main problem is we cannot use this for higher compressive strength building a structure. We cannot use this construction material as a um, as for constructing the load bearing structures, and we cannot use this on a commercial basis. In short, agri-bio-based bricks, we can say, turning crop waste into the sustainable building material. Think if rural India adopted this practices like hempcrete or biobricks, how India and how the farmers of the, what would be the condition of the farmers of the India? Next is nanomaterials. We use nanomaterials in constructing the building by in adding in concrete itself to build a stronger, smarter, and sustainable building. Okay, this material works in a unique way, such as because of this because of the particle size, which is of nanoscale 1 to 100 nanometer, it exhibit a certain unique properties like mechanical properties, enhanced thermal properties, and chemical properties of the overall material is enhanced. Such as, if I talk about the examples, such as nanosilica, if we use, it enhances the compressive strength of the concrete, as well as enhances the reduces the permeability and making concrete a denser material. Even it enhances the resistance capacity. Other maybe carbon nanotube, which are used in high performance concrete. It provides very high tensile strength, which are used in high performance concrete. It improves the crack resistance and flexural strength. Third one is titanium dioxide, which are used for self-cleaning surfaces. Next is nano alumina and nano iron oxides. It enhances the properties of the floor against the abrasion resistance and tiles. Even it provides fire resistance in building materials. Overall, it enhances the mechanical properties of the building, its durability. Hence, the lifespan of the building is ultimately increases. In short, I can say nanomaterials revolutionize the construction by building stronger, smarter, and more sustainable infrastructure. Next, next is 3D printing construction. This is the technology which are shaping the future of the construction layer by layer. How If I talk about how it happens, how we are doing printing in building, constructing our building. First, what we do, we design a 3D model by the help of the software. Later, we print some miniature model. Then we go for concrete mix, where all the metal mixtures, all the concrete is mixed. That mix is printed through the help of the 3D printer by the help of the mm, machines and what we call robotic hands and printer. This building wall is designed in this fashion, where this nozzle is spreading this material, construction material, layer by layer. And in this is a single wall, and in this there is a hollow portions left. Due to this hollowness, it helps in temperature regulation, it helps in thermal insulation, even it act as a natural insulator. If I talk about the other benefit of this hollowness, we can utilize this space for the installation of the electrical and plumbing work. This is India's first 3D printed post house, which are constructed in Bangalore. And this is the Siddipet temple, first temple which are printed with the help of the 3D printer, which are in Telangana. If I talk about the benefit of this technology, here the construction is on a faster note. Suppose if a building if a 2 BHK construction requires 6 months, we can do this by 3D printer in just 10 or 20 days. So the construction pace is increased, as well as we require very less labor, hence reduces the labor needs. We can customize as per our requirement. We can precise and customizable design is possible here. As this is operated by machine, hence we require less material wastage is occurs, and because of that it is of eco-friendly nature. It provides a strong, durable and innovative structure. If I talk about the challenges part, it requires high initial investment. The raw material which we use in printing the 3D printed houses, there is limitation in that. For this technology, we required skilled workforce that we lack, and the regulatory and standardization issue is also there. This material, less material waste, if I talk, it reduces approximately, it requires 40% less material than a normal construction building. It has also less carbon footprint, Hence, it is more towards a greener building. So, moving towards approaching towards my end of the session, if I ask a question, what do you think? Is this 3D printing technology replacing the traditional masonry in coming decade, coming 10 year? Think about this itself. So our future trend lies in bio-based construction material, as we are more focusing towards sustainable building, green building, environment friendly building. Here, even we are using technology intensively. Hence, we are going to incorporate AI and IoT integration in the material, just like 3D printings are hovering around the world. We are more focusing towards the circular economy and recycling in construction materials. As we seen through plastic waste, by the help of the plastic waste, we can create the plastic bricks or plastic road construction. Like Industrial Revolution 4.0, which are going on in construction technology, construction 4.0 is going on. That is automation and material use, smart material use. The future lies in carbon negative material. As we promise the world by 2070, we are going to become a carbon neutral nation. Hence, finally, I can say the modern construction materials are innovations which are shaping the future of our infrastructure. For one concluding remarks, I can say the building of tomorrow won't just shelter us. They will interact, they will adapt, and they will heal themselves. This is my here I'm concluding myself. Thank you for listening me patiently. Now I'm handing this session to the program co-coordinator, Dr. Jitendra Pratap Singh.
Thank you, ma'am, for your presentation. It was very nice. Candidates, you can post your question in your chat box, or you can ask directly. One question came to me, that how can we use this as fly ash bricks in our college? Means if it is economical or if it is.
Sir, it is economical. I compared this in a table, 3 bricks: autoclave bricks, cement bricks, and the red clay bricks we generally use today. If I talk about the overall, on based of the overall parameter, in overall parameter, the fly ash bricks prevails in a good manner.
Okay.
Good evening, madam.
And yes, sir. Sir, you can ask. Shamlal, sir.
Good evening, madam.
Good evening, sir.
Madam, in the lecture, you talked about enhanced mechanical properties when you are using the nanomaterials for construction materials.
Yes,
so
sir.
basically, which mechanical property is enhanced? Which one? Is it brittleness, hardness? Which one?
It's hardness. It's hardness because it enhances the strength. That
Okay.
is, we can say brittleness also, because but brittle here are going to impact in a negative way of the construction, sorry.
What about strength?
Strength is enhanced. As we
Because
know,
strength is
the more
because
brittle
strength is the
material,
main.
sir, as we know, the more brittle material is, the strength wise, it is harder. Okay. But if I talk on other parameter, like the ductility part, that will reduced.
So basically for the high durability, which property we actually desire for having a higher durability of the material?
For high durability, the durability depends on many parameters. I think we all have read about the mechanical properties for eight parameter, eight that comes under 9 parameter like modulus of elasticity, toughness, ductility, and malleability. This all belongs to mechanical properties. So, sir, just brittleness will not decide the strength of the overall strength of the material. There are other factors which decide the strength of the building.
Madam, just
Ma'am,
a
one
second.
question from my side.
Yes, sure.
One more small question.
Sure,
Okay,
sir.
sir.
In the fabrication of composite materials, the bonding strength between the constituents, we have to have high bonding strength, and for that
Yeah.
wettability is concerned. So
Pardon?
how this parameter wettability? So how this wettability is controlled in your construction material?
I'm not getting you. Can you please repeat?
Sir, can you repeat the question?
Yeah, madam. When we are fabricating the composite materials for building construction, as you said,
Yes, sir.
so to have the bonding between the different constituents, because it is, there is no chemical reaction, it is bonding. It
Yes,
is
sir.
through adhesion. So wettability plays very important role. So can you throw some light on this, madam?
Sir, there is reaction. Because of that reaction itself, bonding happens. The
But
word
I
you
think
are using, I'm not
when,
getting it. The
when you are
one,
using the waste plastic with cement, so there is a chemical reaction between the cement and the plastic.
uh, in composite, I haven't used the term the waste plastic. For the use of bricks and for the construction of the plastic road, I said about the use of the plastic. Yes, I said in composite construction material, I talked about the fiber reinforced material, glass fiber reinforced material, polymer fiber reinforced material. In that, what happens? There is bonding between the concrete material and the fiber we are using.
I'm talking about the same thing, madam. Between the surface of the concrete and the fiber. The
Okay, sir.
fiber may be carbon fiber, maybe other materials, right?
Sure, sure.
So
Yeah.
there is no chemical reaction, but only bonding is
Yes,
there.
only bonding will occur.
So this bonding I read in one of the papers.
Yeah.
This enhances when the wettability is high. So I wanted you to throw some light on this.
When 1 minute, sir. When the I'm not getting that word you are using.
Wettability, wettability, wettability.
Okay. Sorry,
No
sir.
issue,
I'm not
no
aware
issue.
of it.
I think
Okay,
this term
okay,
is not
okay. No, no
means
issue.
in civil engineering journal. Ma'am, one question from me that how can we implement this modern building materials in our this civil engineering in BTech or diploma students?
How
I
we,
mean,
can
this
we
modern
use?
building material, how can we incorporate these things in the syllabus so that the student can also learn and prepare themselves for the future?
We can use this through the project work. We have in third or fourth year, we done through micro project and major project. There we can uh, work on that.
Okay, by projects.
Yeah.
Okay. Okay, ma'am. We have one more session that is starting at 7:30. So participant, if you have, okay. Then Dr. Prabhuti, Dr. Prabhuti, if
Hello.
you have any question, you can ask directly or you can paste your question in the chat box.
Yeah, can you hear me, madam?
Yes, yes, yes.
Yes, yes. Sir.
Madam, you are talking about the nanomaterial utilization in building material utilization for the building components and building construction materials.
Sir.
So, can you please tell about the performance of this nanomaterial for self-healing and self-sensing concrete?
I'm not getting your question. If anyone gets that question, can
Yeah, I will ask
Sir,
again.
can you
So,
write it? Right, if you could write the question, I think your audio is
I will.
problem.
Yeah, I will.
Okay. So, ma'am, in the meanwhile, one interesting, the most interesting building material which I thought in this lecture, that the fly ash.
Yes, sir.
Are there some research going on in your institution about this fly ash?
In my institution.
Yes, ma'am. If some project students are doing.
No, I'm not aware of it.
Okay.
Sir, this is a diploma level institution. We are not, we do not provide that much of.
I think the question he has asked it, what about the performance of nano material utilization in self-testing and self-healing concrete? He's asking about the performance of
Yes, I
nanomaterial.
got that. I got that point. Okay. Sir, like like the bacteria and the capsule which I talked, which we are using in self-healing concrete. If we are using the nanomaterials in self-healing concrete, definitely it is going to help because we all know that the nanomaterials are the materials which are present everywhere and which are going to revolutionize the future of ourselves in any manner, either be it construction or health or anything.
Okay. One more question, which material used as bio-based construction material? And I think I think bamboo can be a bio-based material.
Yes, bio-based. Sir, the straw which we generally burn, and we face the problem of the burning pollution, that we can use as a bio-based material.
This rice husk,
Rice
this husk
husk, straw of the
and
rice,
parali,
straw of
etc.
the wheat. Yes,
Parali, etc.
parali. Yes, yes, parali.
Okay. Candidates can the second session is starting at 7:30, so you can join there. And with this, can we conclude this uh, session, ma'am? Can we conclude this session?
Sure, sir. Thank you.
Okay, ma'am.
Thank you, sir. Thank you, everyone.